Let's take a look now at how we can use inverse matrices to solve systems of linear equations. So in order to use this approach, we're going to have to restrict our attention to systems that are square, meaning they have the same number of equations as they do variables. So for example, let's consider the system of equations, two unknowns, x and y, and two equations. Let's rewrite this as a matrix equation. So the idea is the left side two rows can become the two entries of a matrix in the two columns. The first column and the second column take the left side of the first equation and the second equation. On the other side of the equal sign, we put the two entries from the right sides of the equations and make those into a matrix, the first row and the second row of a 2x1 matrix. Now from there, it turns out that you can rewrite the left side as a product of two matrices multiplied together. One matrix with just the coefficients, and another matrix with just the variables x and y. So for example, if I multiply this row by this column, I get 2x plus 3y, which is exactly what we're seeing here. So from this point, you can multiply both sides of the matrix equation by the inverse of the coefficient matrix. So I have this coefficient matrix 2, 3, 1, 2, and I'm multiplying both sides of the equation by the inverse of that matrix. Now the reason to do that is because then these matrices multiplied together, a matrix and its inverse, will give us an identity matrix. So on the right side, we have the inverse times 7, 4. You can simplify the left side because the matrix times its inverse gives you an identity, and the identity times xy gives you xy. On the right side, you can simplify by actually calculating the inverse and then calculating the product. So from this example, we can see that the first row of the matrix xy is the number 2, so x is 2. The second row is 3, so y is 3. That's it. That's how you can use a matrix equation and the inverse of a matrix to solve a system of equations. You write the system as a coefficient matrix times the vector times the matrix xy equals a matrix that has the right sides of the original equations.